All right, hello, it is Miss B back with another geometry review. As always, try this on your own first, and then if you're really stumped, come back and watch the video. Okay? I'm not sure how blurry this is, but hopefully you have this paper from your teacher. Okay? So first one, find a sequence of transformations that takes triangle ABC to triangle A prime, B prime, C prime. Okay, so first thing I'm noticing here is definitely moved. Okay, definitely moved. So from B to B prime, how did that point move? You could do A to A prime, C to C prime. Actually, yeah, let's do A and A. Okay, so A to A prime, I've moved down 2 and left 1, 2, 3. Okay, so down 2, left 3. And so then my points would be here. If B moves down 2 and left 3, it'd be here. And if C does the same, down 2, left 1, 2, 3, I would end up there. Okay? That doesn't really look like A prime, B prime, C prime to me. So what do you think I need to do now? Reflect, definitely. Okay? I'm going to reflect over this line. See that? So let's reflect over x equals -1. That's the line. X equals -1. Okay, that should take me there. Okay, alternatively, we could have reflected over the y-axis first. Reflecting over the y-axis. Then A would be here. Okay, 2 away from the y-axis, so 2 away this way. B would be here, and C would be here. Okay, so this is like our alternate universe here. Then I would move down 3 and right 1. Okay, so any sequence that gets you from one place to another. Okay, there could be multiple correct answers. All right, triangle ABC is graphed. Transform triangle ABC by using this rule. Describe the transformation precisely. So every type of transformation has details that comes along with it, right? Translate, you need to tell me which direction and how far. Rotate, you need to tell me what your center is and how far, and clockwise or counterclockwise. Reflecting, you need to tell me over which line are you reflecting, okay? So transform this. So down here, I've got some blank space. So A is currently at point 3, 3. B is at 2, -1. And C is at -2, 1. Okay? If I'm following this rule, notice X stays the same, Y is now -y. So that means all of my Y coordinates are going to flip signs. So 3, -3, 2, +1, and -2, -1. Okay, so let's plot those new points. You see that? I changed the sign of all my Y values. Okay, so 3, -3. There's A prime. I didn't label these. I'm bad at remembering to label, I'm not gonna lie. Okay, B prime should be here, and C prime should be here. Okay, so describe this transformation precisely. When there's a negative involved, like I'm multiplying by a negative in front, right? Because this is like -1y. There's usually, always, a type of reflection happening. So reflect, but then you need to tell me over what. So all my positive y values became negative, all my negative y values became positive. What line is my pen jumping over right now? The x-axis. So reflect over the x-axis. Okay? So is this transformation congruent, similar, both, or neither? Okay, I would say congruent. Okay, congruent. I guess it's also similar. I think congruent is the most precise answer, in my opinion. Okay, that's because I did not perform a dilation in any way. Okay, if it was similar, there would have been a multiplier in front of both x and y. Okay, if it was neither, then I'd probably be scaling both x and y by different values, right? Similar has to be scaling by the same value. All right, so write an equation that represents each circle. Where to go? I had a little reference sheet. Okay, here are my big main equations for this unit. So which of them has circle? Yeah, the one with radius. Okay, so h and k are the coordinates of my center. Notice those negatives in my equation. That means we need to switch the sign from the equation to the actual graph. Okay, so my x coordinate is -2, so this should be x plus 2. All right, my y coordinate is +4, so this negative means flip the sign. This should be y -4. Okay, and then I need to figure out what the radius is. Okay, so radius is distance from center to edge. So 1, 2, 3, 4. You can count in any direction. You can count this way. 1, 2, 3, 4. Okay, my radius is 4. So 4 squared. You can leave it like that, or write that as 16, because 4 squared is 16. Be sure you can go the other way, okay? If I give you this equation, do you know that my center is at -2, 4, and my radius is 4? You should be able to think both ways. Given the graph, or given the features, what's the equation? Given the equation, what are the features? Okay, this other one. Centered on 0, 0. And what's my radius? 8. I just drew a bunch of dots. I don't even know if there's 8. Okay, so my radius is 8. So if we're following our circle equation, you can write x minus 0 squared plus y minus 0 squared for my center at 0, 0, and then equals 8 squared. But hey, what is x minus 0? That's just x, right? 3 minus 0 is just 3. 4 minus 0 is just 4. So I can just write this as x squared plus y squared equals, and then 8 squared we can say is 64. So again, would you be able to see this equation and know my center is at 0, 0 and my radius is 8? Yeah. Next one. Find the center and radius of this circle. All right. This does not look like this. So I need to use completing the square to make this equation look like that. Okay? To me, it looks like they've already completed the square. So look at this part was 16, this part. Okay? What we're looking for is we want whatever number is here, that's called the constant when there's no letter attached to it, it's just a number. We want this constant to be 16 divided by 2 is 8. And then 8 squared is 64. Okay? If this pattern is true, to go from 16 to 64, then we're done. We've already completed the square. Okay, let's try with this one. So if I have -2, -2 divided by 2 is -1. -1 squared, you need parentheses when you square a negative, is 1. And hey, I have a 1 right here. So I'm all good. Let's just rewrite in this form, okay? So x, and then some other number has to go here. My 64 is the number I'm looking for here. So this intermediate step where I have 8 is the number that will go here. So x plus 8 squared plus y minus 1, right? Not the final one, but the intermediate step. Oops. That looked ugly anyway. Y minus 1 squared equals 144. Now my circle equation looks right. So the center, again, you got to flip the sign because I have these negatives. That means you have to flip the sign. So center should be -8, comma, +1. And my radius, I know that this is r squared. So r squared is 144. So if I square root to cancel, that means r must be 12. Okay, so that was the final answer it was looking for, center and radius. All right. Next one, find the center and radius, but everything's all mixed up and I don't have constants anywhere. So we're gonna need to complete the square ourselves. The very first thing I want you to do is get rid of this constant here. So to undo plus 12, we're gonna minus 12. Notice subtracting 12 on both sides. Now go away. When I'm rewriting this, I want to kind of rearrange stuff so that x is together with x and y is together with y. Okay, so I'll have x squared plus 12x. And then I need to leave space to complete the square. Okay, and then I'm going to have y squared plus 2y plus a square, leaving space. This stuff's kind of in the way. But now I have equals -12. And I can't just have squares on this side. Notice, whatever you do to one side of the equal sign, you have to do to the other. So I'm adding 2 squares here. So I'm going to put some space to add 2 more squares there. Okay, has to be balanced, your equation. So I'm going to add 2 things here. So I have to add 2 things on the other side. Okay, to find what goes in those 2 spots, we're looking at this number. So 12 divided by 2 is 6. And then 6 squared is 36. So don't ignore this number, it'll come back later, but 36 is what's going in that square. And then let's fill in one of our squares on the other side of the equals. Okay, then here I have 2. 2 divided by 2 is 1. 1 squared is still 1. Okay, so I'm going to add a 1 here. And again, a 1 on the other side. So do you see that? I had a lot of students making that mistake on the second check-in. Okay, if you're adding stuff on one side, it has to be added on the other as well. Okay, so when we go to rewrite this in our standard form, we're gonna have x and then something squared, y and then something squared. All right. So again, the number that goes here is that intermediate step. So I should have x plus 6 and y plus 1. Okay, on this side, you just add all that stuff together. Okay, so what's -12 plus 36 plus 1? -12 plus 36 plus 1, 25, equal 25. So then identifying center and radius, center is -6, -1. Gotta flip those signs. Okay, and radius, again, r squared equals 25. So that means radius must be 5. We give you more room on the test, don't you worry. I'm running out of room. Okay. So a parabola has focus 5, 7 and a directrix at y equals 0. Write an equation that says point xy is on the parabola. Okay, so this is saying for any x and any y. That's why we're leaving them as letters. It's not a particular point. So writing this equation should be focus and directrix. Here's my reference sheet I made for myself. Here's my equation of a parabola, okay? H and K, H and K. X minus 5 squared plus y minus 7 squared. And then again, you can say y minus 0, but that's just y. That's just y. All right, and this is all we had to do, okay? So this left-hand side is the point's distance to the focus, and it's equal to the distance to the directrix. Pretty cool? So if I wanted to test a point, like if I would say, I don't know, 3, 2 or something, you could replace every x with 3 and every y with 2 and see if they're equal to each other. I just made that up though. Okay. So consider the line represented by this equation. That looks like my point slope form, which needs two things, a point and a slope. Okay, write an equation representing a different line with the same slope. Same slope, remember, means they are parallel. Okay, and passes through the point 3, 6. All right, so my slope is 2/5. Do not go on autopilot here. For these two equations, x comes first. For this equation, you need to be really careful that you're putting your y coordinate with y and your x coordinate with x, okay? So y minus k, so 6, y minus 6, same slope, parallel lines, 2/5. Okay, my x coordinate is 3, so I need x minus 3. There we go. That's it. That's it. Okay, are these two lines parallel? So to determine if two lines are parallel or not, you need to look at their slopes. So AB, the slope is, you can do change in y over change in x, y2 minus y1 over x2 minus x1, or you can count. So I can see that I'm going down 6 and right 8, and I have 6 over 8. Which simplifies to, okay, -6 is 2 times 3, and then 2 times 4. This is how I simplify fractions. The -3/4. And then CD, down 2, right 3. 1, 2, 1, 2, 3. So down 2, right 3. So moral of the story here is you cannot ever use what I call the looks like it theorem. I can't be like, yeah, it looks like it, so it must be true. No, mathematically, I got two different slopes here. Okay, so no. Slopes are different. Slopes are not equal. If the slopes are equal, then the lines are parallel. If the lines are parallel, then the slopes are equal. Okay, so write an equation of the line that passes through this point and is perpendicular to this line. Okay, good thing I have something called point slope form where I take a point and a slope. Okay, first I need to figure out what my slope is right now. So 2x, your slope is always, if I'm not in point slope form, if you're not looking like this, your slope is always whatever x is being multiplied by. So currently my slope is 2. To find a perpendicular slope, you need the opposite reciprocal. So change the sign and take the reciprocal, flip the fraction. So 2 is secretly 2 over 1. So your perpendicular slope would be -1/2. Okay, so there's your slope, there's your point. Let's put it in our point slope form. So y, my y coordinate is 1, so this will be y minus 1. -1/2 is the slope. My x coordinate is -4, so this will be x plus 4. There we go, that's it. All right, for each equation, decide whether the line it represents is parallel to P, perpendicular to P, or neither. Okay, so first I need to figure out what the slope is here. Okay, so looks like I'm going up 3 over 1. So my current slope is 3. Or 3/1, if you want to write it that way. All right. What's my slope here? Slope is -3. Changed the sign, but it did not take the reciprocal. So this would be neither. So parallel is same slope. Perpendicular is opposite reciprocal. I know you can't see what I'm writing. And then neither would be like neither. Okay, so this one, my slope is -1/3. So it went from positive to negative. And did you flip that fraction over? Reciprocal? Heck yeah, perpendicular. I'm sure your teachers want you to write the actual word. Okay, what about this one? Slope of 1/3. Took the reciprocal, but I did not change the sign, so this is neither. And again, I can tell that's a slope of 1/3 because it's 1/3 times x. This is kind of an exception here. When I see x and y on the same side together, I want to get y all by itself. Okay, here it's kind of okay because I'm just adding and subtracting. That's my special point slope form. But let's move and get y by itself. So I would add 3x, add 3x. Now y equals 1 plus 3x or 3x plus 1. Okay, either way. What is the slope there? Multiplying by 3, so m is 3. Hey, that's the exact same slope as before. So this one would be parallel. Parallel. Okay. Diego claims that he can tell using slopes that this quadrilateral is a parallelogram. Noah looks at the slopes Diego calculated and asks, hey, you can be more specific. That's a rectangle, man. Do you agree with either of them? Explain or show your reasoning. So we need to find our slopes and also the side lengths. Okay, those two features are what makes quadrilaterals different from each other. Okay, so for slopes, let's do from x to w. Okay, I'm going up 1, 2, 3 over 2, so 3/2. From w to z, again, you can subtract your x and y coordinates if you want. So this would be -1 minus 4, -5 over 9, 9 minus a -7, which would be 16. You get the same if you count as well. All right, zy. Be really careful here, you guys. Just because I'm naming it zy, when we're finding slope, you're always reading from left to right. Okay, so I'm going up 3 and over 2. So this one's still up 3/2. Okay, then I need yx. Again, just because I'm naming it yx, I'm still going to count slope going from left to right, from x to y. So it looks like I'm going down 5 and over 16. Down 5 over 16. All right, now I need my side lengths. So maybe I'll just write this like on my sticky. A squared plus b squared equals c squared. If I'm trying to isolate c to just get that hypotenuse, you get square root of a squared plus b squared equals c. All right, so this is what we're going to be using right now. So for my side lengths, from x to w, if you make a triangle, got one side length of 3, one side length of 2. The square root, 3 squared plus 2 squared. Okay. I like to just type in the part under the root because look, I got 13. So I'm just going to leave this as square root 13. Sorry, that's a 3. Okay, this one, if I make a triangle, okay, I've got a side length of 5 and a side length of 16. So 5 squared plus 16 squared. I made my root too long. Right, so 5 squared plus 16 squared. Square root 281. Okay, this one will also have side lengths of 3 and 2. So I know this one will be square root 13. Right, 3 and 2. And this one will also have side lengths of 5 and 16. So I know that one will be square root 281. Okay, now we need to actually take all this information and like analyze it. So what is our proof? So I'm looking for 4 things. Are my opposite sides parallel? Are the adjacent sides perpendicular? Are the opposite sides congruent? And are the adjacent sides congruent? Okay, so let's analyze. Opposite sides parallel. To be parallel, they must have the same slope. So let's look. XW and ZY. Ooh, I'm not even on the camera. XW and ZY have the same slope. Check both pairs. So YZ or YX and WZ, those also have the same slope. Good, so opposite sides are parallel. Are my adjacent sides perpendicular? Okay, so again, checking the slope. XW and WZ. I do not think those are perpendicular. Do you agree? I hope I'm not tripping. No, they are not perpendicular. All right, so they are not perpendicular. To show that something's true, you need to check all of them, but hey, I found one pair of sides that's not perpendicular. No way. Hey, are my opposite sides congruent? Okay, so XW and ZY. Yep, those are congruent. WZ and YX are also congruent. WZ, YX. Good. Are my adjacent sides congruent? No, we got different lengths happening here. Okay, so with all of these features, this cannot be a rectangle. I think, what's his name? Noah? Noah's using the looks like it theorem. He's like, that looks like a rectangle. Bro, that's not a rectangle. The adjacent sides are not perpendicular. Okay, so I would say I agree with Diego. Okay, my opposite sides are parallel and they are congruent. So it is a parallelogram. Sorry, I know you couldn't see. I was trying to squeeze that word in there. It is a parallelogram. Okay, this is kind of blast from the past, perimeter and area. I'm actually gonna skip this one. Skip. Perimeter is your length around and your area is area, length times width. Because I am crunched for time, that's why I'm skipping that one. Okay, triangle ABC is graph. Find point D that partitions segment AB in a 1:2 ratio. Okay, so 1:2, I'm gonna have 3 parts. All right. Segment AB is on the same Y value, so I just need to worry about my X value, okay? So how far apart are A and B? Looks like they're 9 units apart. So they're 9 away from each other. And I'm splitting this up into 3 parts. So that means they will be, each partition will be 3 spaces long. So 1, 2, 3, 1, 2, 3, 1, 2, 3, okay? Do we see how that is 3 equal parts? Heck yeah. Okay, so then this 1:2 ratio, A, B, 1:2. So the segment that is 1 should be closer to A. So I'm looking at this point. So this would be point D. And let's put the coordinates just so our teacher knows for sure which one we're talking about. So 4, 3. Okay, splitting up segment AC into a 1:2 ratio. That one's a little trickier because look, I'm on a slant. We don't need Pythagorean theorem or nothing, okay? So A, I'm just going to label my coordinates just in case. C is 6, 9. Okay, because now I need to consider my vertical and horizontal distance. Okay, so this vertical distance from 1 to 6 is 5. Horizontal distance from 3 to 9 is 6. Okay, so let's look. In my horizontal direction, my x direction, those 2 points are 9, or those 2 points are 6 away, 6 apart. And again, I want 3 parts. So 6 divided by 3 is 2. Okay, so I'm going to come up here and make tick marks every 2. So 1, 2, wait. 1, 2, 3, 4, 5. That's 5? What's wrong with me? Oh, I labeled these wrong. Bear with me, guys. Okay, so this should be Y. Geez, Louise, I bet you're screaming at your computer screen. Okay, my Y values are 6 away. So I'm going to split those up into 3 parts. So every 2 units. So 1, 2, 1, 2, and there's 1, 2. Okay. Along my X, it's going to be a little more complicated because they're 5 away, split into 3 parts. So each divider has to be, what's 5 divided by 3? 1.6 repeating apart. Okay. Right now my X coordinate is 1. So I'm going to add that 1.6 repeating. So that would give me 2.6, comma 3. 2.6 plus another 1.6 would be 4.2. Also repeating. What is happening? 1 plus 5/3, 2.6 plus 5/3. Oh, should be 4.3. Yikes. So in my calculator just now, sorry, I'm scribbling out a lot of stuff. I gotta go. I'm in Miss Cass's room. So what I just did was I took 1 plus, if you just keep it as a fraction, 5/3, there's 2.6, and adding another 5/3 gives me 4.3, and then adding another 5/3 should give me 6. Okay, so these are the points for all of my partitions. Okay, it's a little extra to find all of them, but I did it anyway. Why not? So our first line should be at 2.6, and then 4.3, and then there's that one. All right. So now, again, AC is in a 1-to-2 ratio. AC, so that means 1 part is going to be closer to A, 2 parts closer to C. All right, so I'm going to look at this line and this line. Okay, you can draw both of the dots, and then I know I'm looking at this one. Okay, and they wanted me to label it E. Point E. All right, so then let's write that down for our teacher if you want. So this would be at 2.6, comma 5. 2.6 repeating. There's point E. Okay, I know some of the other teachers teach these partitions and weighted averages a little differently. So if you are like, Miss B, what is going on? Look back at your teacher's notes, look back at your notes from class, okay? The whole point of notes is you're making a textbook for yourself to be able to look back on later, okay? So, yeah, I hope this was helpful. Have fun studying, all that good stuff. You're gonna rock it. Test is on Wednesday. Do your homework. Hopefully you're not watching this too late at night. Okay, bye guys. Oops. Now goodbye.